Rhinehart with 5-Minute Math. I am continuing my lesson on finding roots and factors. This is from Unit 2, Polynomials, Lesson 5, if you're following along in the text. So in the last video, we talked about plugging in all of your possible rational roots into your table and finding the ones where y equals 0. Any of those will end up being a root. We also talked about how do you get a factor from a root. So just a reminder, if you get a root at x equals 2, remember a root is just a fancy word for saying the x-intercept, where is it crossing the x-axis. The factor that matches up with that is when you get this equal to 0. So I'd add 2 to both sides. X plus 2 equals 0. So x plus 2 is the factor. And actually, let's say that was x equals negative 2, because otherwise I would have subtracted it from both sides. So when negative 2 is your root, okay, where it crosses the x-axis is negative 2, then the factor that goes along with it is plus 2. And again, you use all the possible rational roots from the Rational Root Theorem. Check those on the table with the function, and wherever it equals 0, or you can plug it in one by one, and for x, if you end up with 0, it is a root. Now let's say that you end up with a root. For instance, let's say that I have, and I'll look at one from example 3 from the text. If I have h of x equals x to the 4th minus 5x cubed minus 10x squared plus 20x minus 56. With this example, I listed all the possible rational roots using the Rational Root Theorem, and those ended up being 56, 28, 14, 8, 7, 4, 2, and 1, but plus or minus all of those because it could be positive or negative. Again, 56, 28, 14, 8, 7, 4, 2, and 1. Remember, all the factors of the constant divided by all the factors of the leading coefficient. Well, since the leading coefficient is only 1, all of these just would be, were divided by 1. That makes it a little bit easier. So then I would plug in h of x. I would go to my y equals, depending on what calculator you have, type the x to the 4th, minus 5x cubed, etc. Plug that into my table, and then go to the plug that into y equals, then go to my table and check out all of these values. So when I checked out 56, negative 56, 28, negative 28, etc., the only ones that I found that where y equals 0 were 7 and negative 2. So we get roots at 7, and we have a root at negative 2. Now keep in mind, the factor that goes with 7 would be x minus 7, because you'd have to subtract it over to get it equal to 0. And the factor that goes with negative 2 would be x plus 2. Okay, so those are the factors that go with those roots. But since we have a power of 4, you could have up to 4 roots. So we need to see if there are any other irrational ones that we may have not gotten using the Rational Root Theorem. Now, there may not be any more. They may be imaginary, but we need to look for them, and we're going to use synthetic division to do that. So I'm going to erase this part here. And I know that 7 and negative 2 are roots. So I know when I do synthetic division with those, I'm going to start with 0 as a remainder, because that's how it works. So I'm going to start with 7. You could start with negative 2. It does not matter which root you start with, but 7 is the root. And then I do all the coefficients from my polynomial. Remember, if it skips, like if it goes from x cubed just to x and it skips x squared, you have to put a 0 in for a placeholder. But it didn't skip anything here. It went x to the 4th, x cubed, x squared, x, and then the constant. So I wrote those out. You bring down the first value, 1, and then I multiply. 1 times 7 is 7. That goes here. And then we're going to add. Negative 5 plus 7 is 2. 2 times 7 is 14. Put that here. Now add. When I add negative 10 and 14, I get 4. 4 times 7 is 28. Put that here. Add negative 20 and 28, I get 8. 8 times 7 is 56. Put that here. Well, negative 56 plus 56 is 0, and that's your remainder, and it should be if it's a root. Now I'm going to do this again with the negative 2 because we found that that was a root also. Okay, so we've taken out the 7. Now we're going to take out the negative 2. So bring down the first value, 1. 1 times negative 2 is negative 2. So 2 plus negative 2 ends up canceling out, and you get 0. Well, 0 times negative 2 is 0. 4 plus 0 is 4. 4 times negative 2 is negative 8, and when you add those together, you get 0, which you should because it's a root. Now, remember, this was x to the 4th. Then we took out a root, so now this is x third. And then we took out another one, so now this is x squared. This is x, and that's the constant. So now that I've taken out the root of negative 2 and the root of 7, I'm left with x squared. There is no x because it's 0, so x squared plus 4. This is what I'm left with. So x squared plus 4 does not factor with real numbers. It will factor with imaginary numbers, which I'll do in a second. But factored, this thing becomes, I've got that x minus 7 because of the root at 7. I've got the x plus 2 because of the root at x minus 2, or sorry, at negative 2. And then we have that x squared plus 4. Now this is in factored form, but if you want linear factored form, you actually have to factor this even more. And this can factor, but again, it's with imaginary numbers. That is a sum of 2 squares. That would factor into x plus 2i and x minus 2i. That's one of those special types of factoring. That's a sum of 2 squares. So if I wanted linear factored form, I'd have my x minus 7, that's for the root at 7, my x plus 2, that's the root at negative 2, and then I have x plus 2i and x minus 2i. Let me erase this because it's in the way here. So that's linear factored form. And if you want all the roots, remember, we have a root at 7, we have a root at negative 2, and then we have 2 imaginary roots. If you notice here, x plus 2i, x minus 2i, if I set x plus 2i equal to 0 and solve, I'd end up with x equals negative 2i. So that's another root. And that's imaginary, so it won't actually cross the x-axis because that's imaginary. And then the other one, if I set x minus 2i equal to 0 and solve, I get positive 2i. So these are all the roots. Now 7 and negative 2 are the only real roots, but you also do have